Hello friends, today we will see here the reactance relay. In the reactance relay, the operating torque is obtained from the current and restraining torque by the current and voltage of the directional element. This implies that reactance relay is an overcurrent relay with the directional restraint. The directional element is so designed to give the maximum torque angle of the 90 degree. These are the some important points in the shortly. That means there are the two torque is produced. The first is operative torque, it produced by the current. Second is the restraining torque, it is produced by the current voltage directional relay. Then the positive torque by overcurrent element, the negative torque by the directional unit. The directional element designed for the maximum torque angle, that means the 90 degree. Then the reactance relay is an overcurrent relay with the directional restraint. Reactance relay is suitable for the short transmission line because its operation independent of the arc resistance. This is the diagram for the reactance relay. It is the simplest arrangement of the reactive distance relay. It is similar to the induction type of the relay. It has a 4-pole, pole 1, pole 2, pole 3 and the pole 4. It has a operating coil, polarizing coil and the restraining coil. So the current polarizing coil fluxes goes upper polarizing coil magnet to the lower magnet through the cylinder and this iron core. So due to this, flux is induced in this cylinder whose direction is perpendicular to the plane of this paper. Okay, and it flows up and down at the side of the cylinder, which are opposite of the other two poles, that is operating coil magnet pole and restraining coil magnet pole. The current in the cylinder portion, which is opposite operating coil pole, react with the flux of that pole and produce the torque tending to close the relay contacts, and current is in the cylinder position and this current is in the cylinder portion opposite to the restraining coil pole, react with the flux of that pole and produce the torque that is proportional to the voltage and current. It is tending to open the relay contacts. So in the simple way, it produces the two torque. First is the operating torque and second is the restraining torque. So operating torque it produces, it is the interaction fluxes due to the current coil, due to this current coil of the fluxes in the pole number 2, pole number 3 and the pole number 4. And the current coil, it is nothing but the restraining torque. It produces the restraining torque in the interaction of the coil number 1, pole number 1, pole number 2 and the pole number 4. So because of this, operating torque will proportional to the square of the current and restraining torque will be produce the product of the voltage and current. That means when the torque is produced, so due to this torque, the disc is moment. तो डिस्क क्या करेगी, रोटेट करेगी, मोमेंट करेगी. बट व्हेन द फॉल्ट occurs, so voltage drop. So if the voltage drop, that means the current increase and circuit will be the trip. So according to this is the working principle of this reactance relay. Now there is the some it has a some torque equation. It has a torque equation. So for this torque equation, we have to consider the torque. Okay, we have to consider the torque equation. This torque equation, T is equals to K1 I square minus K2 VI cos theta minus tau. So when the balance point of the net torque is 0, that means when the balance point is there, the net torque is 0 and we get the K1 I square minus K2 Vi cos theta minus tau. So we get, suppose K1, we have to solve this equation. K1 I square is equals to K2 Vi cos theta minus tau. So this K1 I square is nothing but the operating and this is the restraining torque. Then we have to solve again. K1 is equals to K2 upon Vi cos theta minus tau. And this Vi means the Z. So I get cancelled and this Vi, that means the Z, and Z means the impedance. So K1 equals to K2 Z cos theta minus tau. So suppose we have to adding this capacitor. In the previous diagram we have seen there is the capacitor. So yes, if we have to adding this capacitor, so what happened? So when we have to adding this capacitor, the torque angle is adjusted as a 90 degree. So that we have to write down the K1 equals to K2 Z cos theta minus 90 and K1 equals to K2 Z sin theta. So what is this? This is nothing but Z sin theta, that means the X, that is the reactance, and Z cos theta, that means the R, that means the resistance. So using this impedance triangle, there is the Z, R and X. Okay. So Z sin theta, that means the X, that is the reactance. So we have to consider here the, in the replacement of this, we have to write down X. So Z sin theta, that means the X, and K1, K2 is equals to constant. So this is nothing but, this is the torque equation of the reactance relay. And this, there is the one characteristic. So according to this characteristic, we have to see the vector whose head lies on the characteristic such that it has a constant magnitude of the X as shown in the above. So we have to see here the relay operates on the reactance only, and the constant X means the, this constant X means the straight line parallel to the X axis on the Rx diagram. This diagram is called as the Rx diagram. So for this operation of this relay, the reactance seen by the relay should be smaller than the reactance of which the relay is designed. So this is all about the reactance relay. Thank you.